Okay, this diagram over here illustrates the situation. We have a rectangle PQRS with an area that's 10, and that's why if this dimension is h, this dimension is 10 over h, because length times width gives us 10. Then we're told there's a point A on RS, there it is, and a point B on PS, there it is, such that the area of triangle QAB is always 4. And that means the area of the red rectangles have to add up to 6, because 6 plus 4 gives us 10. So there's the area of the rectangle. There's the area of the triangle. It's possible to prove that in order for that to be the case, x times y, x is PB, y is AR. The product of those two lengths has to be 2, and that's what we're going to show. And when that's true, x plus y, well, it could have different values depending on what x and y are. By the way, if x times y equals 2, then y equals 2 over x. That'll be key later. I'll send a link to this graph, and when you click on where it says set y equals the square root of 2, it'll move points A and B to the places where that's true. All right, so here's the idea. The area of this rectangle right here is 1/2 of h times x, because these are right angle. That's a right angle, and this is an altitude and a base. For all these rectangles, it's going to be 1/2 the product of the altitude times the base. So instead of putting the 1/2s here, we'll just multiply the area of the red area, which is 6, by 2, which gives us 12. Okay, so the area of triangle 2 is 10 over h times y, half of that, but we accounted for the 1/2. And finally, this triangle 3 is this base times this height. Again, we took care of the 1/2 by multiplying the 6 by 2. And if you multiply this all out, here we got to use FOIL. So the product of the two first terms is 10. The outer product is minus 10y over h. The inner product is minus h over x, minus hx. And finally, minus x minus y is plus xy. And here's what's cool. Hx minus hx cancels out. 10y over h minus 10y over h. Subtract 10 from both sides. There we prove that in order for the area of this red or green triangle to be 4, x times y has to equal 2. Now we want to minimize x plus y. Okay. And, if you have a rectangle that has an area of 2, the rectangle that has the minimum perimeter with an area of 2 is a square. And so that's why we can go like this, square root of 2, square root of 2. If you want to use calculus, here's the function we're trying to minimize. F of x equals x plus y, but we know that y is equal to 2 over 2 times x to the minus 1. Take the derivative, set the derivative equal to 0. You've got these critical numbers. You could apply the first derivative test to show that plus square root of 2 gives you a minimum value for x plus y. And here's proof right here. There's the original function. And there's the minimum value. Of course, if we had used minus the square root of 2, we'd have another curve down here, and this would be a relative maximum. Okay, there you go. Hope that helped. If you have any questions, post a comment.